Guys, welcome back to my channel. Today I am going to explain one of the coolest problems in computer science. It's the Tower of Hanoi. So it's a small game, but it's teach us a big concept, recursion, by the end of this video. And you will understand what the Tower of Hanoi is and how it works, how to write the code, and even how to calculate the total number of moves like this. So, all right, let's get started. Okay, so first, what is this Tower of Hanoi? So, it's a simple puzzle with three rods. Not road, it's three rods. Okay, so name A, B, and C, and we have few discs of different sizes stacked on one rod. So mm, our goal is to move the whole stack from rod A to rod C using rod B as a helper, right? So we can move this disc like this. Okay, uh, but you can't just move them however you want, because there are three main rules you must need to follow, right? So mm, rule number one is you can only move one disc at a time, at a one time. It means you can move like this. You can't move this whole stack, the whole discs, or the two discs. You can't do it. It's a rule number one. Uh, so rule number two is you can only move the top disc from any rod. It means like this, like this. You can't move this disc or uh, this disc. You need to first move this disc, and after this is the first disc. Now you can move this, right? It's a rule number two. And rule number three is you can't place a bigger disc on top of a smaller disc. It means you can't do like this. So this is a smaller disc, and this is big one. So you can't do like this. Do like this. Right. So it's a main rules. So okay, our job is to move all the discs from the first rod to the this is the first rod A, first rod to the last one, following just these three rules. Okay, now you know three rules, and I think we can solve this puzzle. So now let's talk about how we can solve this problem, right? So we can use a method called recursion. Right. So what is the recursion? Actually, recursion means a function. It's a function that calls itself to solve the smaller parts of the same problem. Recursion. It's a recursion. It's a function, right? Okay. So then we can solve this puzzle first, and remember that three rules, right? Okay. uh, we can move this smallest these two rod C as a helper. Rod C is helper, and this small disk to road B, and we can move these two, this one, and we can now move this biggest disk to road C, and we can move this smallest disk to road A, and this to road C, and this smallest disk to road C. Okay, well done. Now we solve this puzzle. Yeah. So these steps keep repeating again and again until you are left with only one disk. That's the base case. Okay. So actually this is why recursion is so powerful. It takes a big task and break it into smaller, easier parts. Right. So we can add more disks like this, and we can solve it using some formulas. Let's try to do this one. Like, remember three rules. You can
75 years later.
You can only move one disk at one time, and you can only move the top disk from any road. And rule number 3 is you can't place a bigger disk on top of a smaller disk. So however, we need to get this biggest disk to road C. Yeah, we did it. Like this, right? And it's repeat. And this moves 255 moves. 1 2 3 5 like. And 250, 53, 54, 55, like this, right? So it's this is the Tower of Hanoi. Okay, now let's look at the code that solves this problem automatically using recursion. So recursion is a function. So this is a Java code. You know it. This is Java code, and this is Apache NetBeam IDE. Okay, so let's break it down line by line so you can understand it easily. Okay, this is class Tower of Hanoi. This is our Java class where all the logics are in. This is solve method. It is a recursive function that moves this from one row to another, and it has 4 parameters. It has 4 parameters. Int mean integer, int n mean number of disks, char mean characters, char from mean source road. It's like road A, and character aux mean auxiliary. It's middle road, or helper road. So chart 2 mean it's a destination road. Destination road. Okay. So this is our base case. If there's only one disk left, we just move it directly from the source to the destination. That's the simplest possible move, right? So then we have the recursive steps. This one, right? Here's what's happening. First, we first move the top n minus 1 disk from the source to the helper node using recursion function. And second one, then we move the biggest disk. It's a disk from the source to the target node. And finally, we move the n minus 1 disk from the helper node to the target node. That's how recursion solves the whole puzzle step by step. Okay. Uh, Now we in our main method we just call solve n a b c. Okay, n mean disk, count of disk. We can change this 4 or 5. 4, 5. Okay, so we are using road B as a helper and we want to move everything to road C. Okay, uh, we can just run this file. Yeah, when we run this program, it prints out every moves we need to make in order. So as you can see, all three disks are successfully moved from A to road C by following this following the that three rules, like right. So move disk A, move disk 1 from A to C, A to C, and move disk 2 from A to B, move this 1 from C to B, move this 3 from A to C, move this 1 from B to A, 2 from B to C, move this 1 from A to C, like this. Okay, it's mean move this 1 from A to C and move this 2 from A to B and move disk 1 from C to B and move disk 3 from A to C and move disk 1 from B to A and move disk 2 from B to C and move disk 1 from A to C, right? So let's try some another thing. We can change this number to this any number. Just put number 4. It mean we have 4 disks and it change 5. Now we have 5 disks. Okay, sorry. Imagine now we have 4 disks. We can run it. Okay, we got this final output. It's mean like this. We have 4 disks. Okay. it say move this one from A to B. A to B. And move this 2 from A to C. Right. And move this 1 from B to C. B to C. And move this 3 from A to B. Okay, A to B. And move this 1 from C to A. Move this 1 from C to A. Right. And move this 2 from C to B. Move this 2, this one, C to B. Right. And move this 1 from A to B. This 1 from A to B. Right. And move disk 4 from A to C. A to C. Right. And move this 1 from B to C. B to C. Right. Okay. Move this 2 from B to A. B to A. Okay. And move this 2 from B to A. B to, oh, what the hell? Move this 2 from B to I. We did it. So move this 1 from C to A. C to A. Right. And move this 3 from B to C. To C. Okay. And move this 1 from A to B. A to B. Okay. And move this 2 from A to C. A to C. Oh, and move this 1 from B to C. Yeah. That's it. Okay. So we can successfully move from A to C by following the rules. Okay. So there's also a simple formula to find out the total number of moves needed for disk 1 or 1 2 3 4 or any disk. So that formula is this one. That formula is this one. And so if we have 3 disks, the total moves are 7 moves. If you had 4 disks, it would be 15 moves, and so on. Okay, so that's how the Tower of Hanoi works and how recursion makes it super easy to solve. So it's a great example of how breaking the big problem into smaller sub-problems can make coding much simpler. So hope you learned something new today. If you like this video, don't forget to hit that like button and subscribe, and drop a comment if you want more data structure and algorithm explanation like this. So thanks for watching and see you in the next one. Thank you.